Some other benefits that we get are privacy, because we don't have to upload all of the photos to Watson over the internet. It's all locally on your device, so secure. What Watson is bringing to the table is we allow you to train custom models. You can download already pre-built models on the Apple website to do image classification, but the results you're going to get from that is very general. So, for example, with a pre-built model, you'll get something like car wheel if you feed it this image. But if you train your own custom classifier, you can get more specific details like broken windshield, minor dent, flat tire, etc. And then again here, with the general model, we can get shoe. But if we train the model ourselves, we can teach it things like what Adidas, Nike, or New Balance shoes look like. And with fruit, we can train it to detect how ripe the fruit is versus just that it's an avocado. And the way we do that is really easy. We have Watson, we upload our training data, and it gives us an ML model. In the iOS, we have also provided an SDK. And so it makes it even simpler. Instead of having to download the model onto your laptop, drag it into Xcode, and rebuild your app every time you want an update to your model, and then have to redeploy the app to the App Store. That can be a little bit tedious. So in our SDK, you can actually just put in your model's ID, and it'll automatically download any changes that you make to the model on the cloud onto the device whenever the user has Wi-Fi. So you don't have to redeploy your app every time you want to make a change to your model. Yeah, and I think so we can get started with the workshop.
Awesome. So if everybody could go to this URL, we can just get started. I'm going to go right alongside you guys and work through the workshop so we can all stay together. If at any point you have any questions, just raise your hand, and Nick or myself or Josh in the back here will come and help you out, and we'll make sure everybody gets through it. So from that URL, I'll put it back up real quick if anybody needs it. You'll see a few options at that website, and we want to go to the advanced models or advanced tutorial single model. Don't worry about advanced; it's not really that advanced. It just we go into a little bit more detail. So, who has ever heard of something called Carthage? It's a package manager for iOS. Nobody. Okay, so I'll assume nobody has it installed already. We're going to want to get that going. Our app relies on it so that we can pull down our SDK. So if we go to the Requirements tab, which is the second page, it'll tell you how to install it. You can just click it and download it right there. We're going to be needing that, so if everybody could just get that going off the bat, it'll help a lot later on. And again, for anybody who's sitting in the chairs, you don't have to, but if you would like to sit at a table, it might be a little bit easier typing and all that stuff. It looks like we're getting power now, so. And this website will always be up. If you want to go through it again on your own time later, feel free. So the application that we're going to be developing today is we're going to create a custom classifier that can identify different types of cables, USB, HDMI, VGA, things like that. So we're going to have some up here that you guys can use to take photos. But I just want to really briefly talk about what it takes to create a custom classifier. So obviously, we're going to have to create our training data. Now, with visual recognition, when we create a custom classifier, we're using something called transfer learning. Essentially, what that means is we already have this really big model that's pretty good at identifying objects kind of at a high level. Now, what we're going to be doing is creating our own training images. For example, we'll take photos of USB cables. And essentially, we're going to give that to Watson, and it's going to retrain on that specific segment of photos, and it'll create a new classifier that's really good at identifying those objects. Now, to give you some details, in order to create a custom classifier, you need at least 10 photos of the object that you want to classify. But of course, you can take more if you would like to. So in this example, we are creating a custom classifier for HDMI cables. And you'll notice that we're taking photos from a variety of different angles with different backgrounds. Some include the hand and the fingers, some don't. So you really want to think about, when I'm going to be using this classifier, what kind of environment will it be in? And you kind of want to train for that. And the more variety you give it, the better your classifier will be. So we have some cables. This will be the first thing that we do, just so that we can gather all of the data at the front end, and then we can just start using it. So since we have plenty of time, there's some cables over here. And what we want everybody to do is take the HDMI cable, for example, take about 10 photos, take about 10 photos of the USB cables, and just have them handy for your own personal use so that we can train our own classifiers in a few minutes. So they're over here at the table. If you want to go and grab them, share them with your neighbors, take, like I said, 10 photos minimum. Think about, maybe taking some with the table in the background, maybe some with the carpet. Get creative to create a variety of photos. Yeah. So they don't have to be that. I would say that you'll get the best results when you do crop it down, because you'll be kind of minimizing the extra data. So in general, you would be kind of minimizing it to the actual object. Right. So I'm noticing not everybody is going to take photos or very eager to do that. So if you want to just download a training set, if you go to that URL, ibm.biz/connector-images, you can download a data set that's already been taken for you. If you want to take your own, feel free, but that's a little shortcut if you'd like to do that. So if you go to this URL and you download it, you'll find a zip file, and within that zip file is another set of 4 or 5 other zip files. Don't unzip each of those, just unzip the first level. So does everybody have the images, or maybe working on taking photos, one of the two? Yes, yes, yes. All right, we'll just move along then. So the second thing that we're going to be needing is an IBM cloud account. This is what we're going to use so that we can create our services and then create our custom classifier. So from the register your accounts page, if you just click the IBM cloud, that'll take you to register. In addition to that, if you would like to deploy it to an iOS device, you will need an Apple ID. So if you already have one, that's good. If you need one, go ahead and register for one. And after you go through the sign up, it should email you a confirmation, and just, everybody should know how to create an account. Yeah. Yeah. So the URL that I put up initially, the ibm.biz URL, that'll be up, and you can access that anytime. Sure. Here, I can actually pull it up for you. Mm-hmm. All right, anybody having issues creating your account? No? Oh, you do? All right, Nick will help you out. Everybody else good? All right. So the next thing we're going to do is we're actually going to dive right into Watson Studio, which is the sort of environment that I mentioned previously. If you go to the Create Your New Project, it's the 5th page. The URL at the top will open up Watson Studio. And it'll look something like this. Now, the first thing that we're going to want to do, just to make sure that we have all the tools necessary that we can just get going, is up here in the top right corner, you should see your initials. If you click that and go to Settings, now I already added it, but you should see an option to Add Apps, and you're going to want to click that and add Watson Studio. No, it is browser-based. So. So after you add Watson Studio to your account, we can just go back to the first page. If you just click Watson Studio, it'll take you there. And what we're going to do is click New Project. We are going to select the basic option and then hit OK. We need to give it a name. We'll just call this my first project and then click Create. So after it creates the project, you should see something like this. Now there's two tabs that I really want to point out. This is primarily, I would say, the most important tabs in the entire dashboard. The first is the Settings tab. Now what we want to do is make sure that Watson tools are added. This will just give us access to some additional tools that we want to use when working with Watson services. After you check the box, just click Save. OK, Nick can help you get those. So now that we have added that, still in the Settings tab, now we want to add our visual recognition service. So if you scroll down about halfway, you'll see an item that's labeled Associated Services. Right now we don't have any, but if you click Add Service, select Watson, this will open up a page of our catalog of different Watson services that you can add. So if you scroll down, you should see visual recognition as an option. We're going to click Add. Yeah, so in the Settings tab, and then scroll down about halfway, and you'll see Associated Services. And then click Add Service, and select Watson. And then after that, scroll down towards the bottom, and you'll see visual recognition. Click Add. Now, I already have an instance running, and I'll just select that. But since you don't, you're going to want to select the Lite option, which is our free tier, and then just click Create. So now in our associated services, you should see your instance of visual recognition for your project. Now, the second tab that I mentioned is like kind of the most important part of Watson Studio is the Assets tab. So if we go in there, we can see right now there's nothing, but this is where all of our data will live, our models will live. So you'll see that our data assets are empty right now. If you click Browse on the right-hand side, the files that you downloaded, or maybe you took them yourself, you're going to want to navigate there. And you'll see that I have these 4 zip files: HDMI mail, Thunderbolt, USB, VGA. And we're actually just going to select all of them and click Open. And it's going to begin to add them to my project. It's going to try to. Let's try adding them. So if you have any problems and you get this kind of pop-up, if you just say create new, it'll try and add it again and add it there. So now we have our data assets, and these are our training images that we're going to use to create our custom classifier for VGA, Thunderbolt, HDMI, and USB. So now they live in our project, and we want to use them. So again, from the Assets tab, we're just going to scroll down towards the bottom, and you'll see a Models section. And we want to create a visual recognition model. So if you just click the new, Create New Visual Recognition Model, it'll take you to this page. So first, we can rename it. Instead of calling it default custom model, we'll call it connectors model. And now you can see on the right-hand side, we have all of the assets that we just uploaded. And then we have in the middle an area where we can create classes. So first, I'm going to create a class and call it VGA. And then on the right-hand side, I will just drag it in and add it to that new class that I just created. And you can see it's adding them. And now I'll create one called Thunderbolt and drag that in again. And you can do this for each one of those zip files. HDMI. Drag it in. And then USB. Do you mean if you just created one class and added them all into it? It would generally classify any connector as whatever you called it. So it just wouldn't be specific. And at that point, you might as well just use the general model because it would, yeah. I'm sorry, I missed half. Mm-hmm. So it's not a requirement, it's more of a suggestion. It'll make your training images better, but yeah. So is everybody good up to this point? Everybody's tracking that wants to? Yes? No? Yeah. What do you mean? Like other services that you could use? I haven't used any of them. I think you can probably do it with AWS as well, but yeah. So after you've added your training images to the specific classes that you created, the train model button will become available. And if you click it, it's going to start training. So now it's training your custom model based on these classes and the training images that you provided it. So at this point, while it's training, it's going to take a couple minutes. We can go ahead and get started with our iOS app that's actually going to use the custom model. Now, also, just to provide some context, training this classifier will take a couple minutes, maybe 5 minutes at max, and it depends on how many classes that you're creating. But to give some context, if you were to try to do this on your own, you would need probably 1,000 times more photos than we've provided it, and it would take hours, on the order of hours, rather than minutes. Well, because if you were to try and do it yourself, you would have to train and build the entire model. Using Watson visual recognition, like I said, we're using something called transfer learning. So rather than having to retrain the entire model, we're just retraining it on that specific subset of images at the end. Yeah. That exists somewhere, but it doesn't necessarily concern us when we're creating our custom classifier. It just kind of exists. It's essentially a label. Yeah. It is. I mean, so it's learning from these training images what an HDMI cable is, what that connector looks like. No. All right, so it's still training, and let's go ahead and start working on our iOS app. So it's already built, so you don't have to write a ton of code, but we do need to get the code. And so if you go to the 8th page, it's called Getting the Code. And you're going to need to open up Terminal and use Git in order to clone this repository. So after you've cloned the repository, we're going to change directory and actually go into that one. So yeah. Is everybody still waiting for the git clone? Is anybody else having issues with git, or everybody's good? All right, I'll assume everybody's good. So we're going to change directories, so just cd into the visual recognition with core ML directory. And once you're in there, you're going to want to call this Carthage Bootstrap Platform iOS. That's also in the tutorial, if you just want to copy and paste it. And what this is going to do is pull down the SDK so that we can use it in our app. It might take a few moments with the network. Is anybody having issues with it? Is it a little bit slow, or is it working? Is it? Oh. Is everyone good? Is it still working? No? Okay. All right, we'll hang tight. What's that? Oh. I'm sorry, I missed the question. I still can't hear. I'm sorry. Yeah, so it's pulling down the Watson SDK and it's building it for our project. So it's available to us. Okay. Did it finish for anybody, or everybody's still waiting? So after it's done training, you can test it in the browser, and that's a decent indicator of if it succeeded or not. It's not so much a matter of if the training succeeded, because it's going to train on whatever you gave it. It's more a matter of your custom classifier is only as good as the training data, so only as good as the images that you gave it. And so sort of as I guess a rule of thumb is that, for example, if you're building a classifier that you're going to deploy to iOS devices, it's generally good to think about the quality of the images that are going to be provided. So if you know it's going to be on an iOS device, it's a good idea to take your training images with an iPhone, because that's the hardware that your users are going to use. So if you can kind of eliminate some of these subtle differences, for example, if you took it with high definition like HDR camera, the images will be slightly different than with my iPhone. So if you can kind of remove those factors, it'll improve your classifier, if that makes sense. Well, I mean, like I said, there's a tab where you can test it, and that would, be an indicator of the quality. No. I don't believe so. I don't think so. Yeah, so as you can see, mine just finished. If I were to add more photos, if I uploaded more to my data assets and then I added some more photos to HDMI, it would give me an option to retrain the model. And that's sort of what Nick was pointing out earlier, is that there's this concept of continuous learning. So after I deploy my app into the App Store and I have it using my classifier, I can actually on the back end add more photos, improve my classifier, and retrain my model. And my users will get that update as soon as I want them to without having to push a full update to the application, to the App Store. But also I think the question you're asking is if you could retrain it from the phone. So you could use the SDK to retrain the model. I'd say in general, that's probably bad practice to give your users that much control. What you would want to do is take that, say what your user is taking a photo of a USB cable, and it's classifying it as HDMI, which is clearly wrong. You would probably want them to upload that photo somewhere else and have somebody on your team kind of verify, oh yeah, this is wrong, it should be reclassified, and add that to our retraining data. But I mean, you could from the phone if you wanted to, but you might end up with a poor classifier if people are just adding bad images, you know. So has anybody's Carthage finished building? 1, 2, 3? Oh yeah, pretty much everybody it seems. All right, so that's good. If you're still waiting, no worries. As you can see, my model just finished training. I would assume most everybody else is either finished now or will momentarily, which is good. We're going to be using that. So now from the command line in the same window, if you just say open and then space period, it'll open the Finder window. And we're going to open the CoreML Vision Xcode project. Which I already have open. The main file that we are going to work with is the camera view controller. Now, don't worry about all the code necessarily. It's already been built. We just need to modify it for our specific use, which is using our own model. So you'll see here it's looking for something called a model ID. And then if you go to this other file called credentials.plist, you can see that there's another space where you can add your API key. So those are the two items that we need to add, and then we can actually use our classifier. So I'll show you where to find those two pieces of information. So for starters, from this window, you can see under our model name, it says associated service. And if you click the name there, it will take us to this page. So if we scroll down, you can see the model that I created, connectors model. Now, if I just click the copy model ID, that's what we need. And if we go back to Xcode, you can see we're passing it an array of strings of our model IDs. You could give it multiple model IDs if you had multiple. But since we just have the one, I'll just put it right there. Now, the reason why you might use multiple classifiers is sort of like in the example where Nick showed a flat tire, a cracked window. You would probably have multiple models to identify different severities of damage. So you might have one model that just identifies damage at a high level, whether it's a flat tire, a cracked windshield, a dent, whatever. And then you would have specific classifiers that would identify, oh, this is a small crack, a major crack, you know, different severities of windshield cracks, for example. So we pasted our model ID there. And now the last piece that we need to make our app run is just to get the API key. So we go back to the web browser and scroll up. There's a tab called Credentials. If you don't see anything here, you can just click New Credentials, and it'll create new credentials for you. I already have some. And so we'll just expand it, and you'll see an element labeled API key. We'll just copy that, go back to Xcode, and then paste that into our credentials.plist. So now this tells, yeah. Yeah. So now we're telling our application how to log into our account and specifically which model to use. And that's all we need. So now you can click the Run and Build. And this will use the iOS simulator. So it's starting the app, it's compiling the model and downloading it from Watson Studio. And now it's ready to go. So there's a couple things. If I were to retrain the app and I wanted to update it, there's a button here that would just grab it again. Since it's up to date, it saw that and it just stopped because there's nothing to update. Yep. And this is just an example. If you were to deploy it into your own app, you probably wouldn't have a button that explicitly said update because you probably wouldn't want your users to have to worry about that. You would probably just have it passively kind of look to see if there's an update in the background and then fetch it for them. So now we can test it. So if you click on the other button, this will bring up the photos, and I already have a photo of a USB cable. And you can see almost instantly, it was able to identify with 80% confidence that it is, in fact, a USB cable, and it's not anything else. Now, 80% probably doesn't seem like great, but remember, we only passed it a few photos. If I really wanted to improve it, I would pass it, tons more training data. I would probably not use photos from one or two different scenes. I would probably expand it. For example, in this example, I didn't have any training photos that had my keyboard in it, for example. So does everybody have the app, is working on building the app? Does anybody need help getting that going? Okay. Oh, so instead of taking a photo, you want to just identify it? So you would just have to build that yourself? Yeah, so in this example, we're just giving it a single photo. But you saw how fast it was. And so you could build your app such that it just extracts the frames and is classifying it kind of on the fly like that. And that's sort of how you would do video and kind of reach that sort of real-time classification. So it's actually not making a network request. So since we built the model as a core ML model, it's actually running on the hardware, which is how we get near instant classification, because it's not sending any network requests at all. You can't do it in the simulator, but if you were to go airplane mode, it would still work. Exactly. Yeah, the only time you need to make a network request is to download the model or update the model. And of course, if you were training it, you need a network request to provide it, but that's sort of separate. No. So right now, in terms of like running on the hardware, it just supports Core ML. You could use it from Android using the REST API and just point it to your specific custom model, but it's not offline. So we still have about 30 minutes. Does anybody have any other questions or needs additional help? Yeah. Yeah, so you can. The limitations between the free and the paid version of visual recognition is just how many classifiers you can create. I forget what the limit is. I think you can make 2 custom classifiers in the free version, in the light plan. And then beyond that, you have to switch to a paid model. Sort of the other benefit along the lines of payment is that when you are utilizing the model as a core ML model, you're only charged for training because you can't really charge for passively classifying on the app. Whereas if you were to use the REST API, it's like a per API call payment plan. I would have to check. I don't believe you're charged for actually downloading it, but I think it's just training. But don't quote me on that. So does everybody have the app built and running that wants to get the app built and running? So there's kind of a bonus. Like I showed you, when we test it, the classifier is good, but not necessarily great. The confidence score is high, but it's not, it could be better, right? And so if you are so inclined and you'd like to kind of understand what improving your classifier looks like, now would be a good opportunity to take some new photos with the cables that we have, and we can show you how to actually retrain and improve your classifier. And you can see it happen, almost instantly once we retrain it. Mm-hmm. Oh, interesting. And that's just in the simulator, though. Okay. Okay.
So a lot of you might have noticed if you just drag and dropped one of like the stock iOS photos that they give you, it's extremely high confidence, like 90% HDMI or something like that. And so the reason that is because we didn't provide a negative data set for our training. And what the negative data set does is it kind of tells us, tells the model what we're not looking for. So if you just show it some pictures of the HDMI cables, it doesn't really know what you want it to focus on whenever you're showing an HDMI. It might think you're talking about the background or your hand. So it doesn't really know what to focus on. So we want to upload photos that are kind of visually similar to HDMI cables, like ropes and things like that, and also things that are in the photos in your training data, like the backgrounds in your hand, and put those all in the negative set, so it can kind of understand a little bit more what you want it to actually focus on. And to kind of demonstrate that, we're going to play a little game. So I'm going to show you a series of images and try and remember what they look like, and then yeah. So this is A. Remember what it looks like. This is B. How many of you think this is A? One person. How many of you think it's B? 3 people. Come on, everybody needs to vote. Who thinks it's A? 3. Who thinks it's B? All right, we'll get back to this. Here's another example of B. Here's another example of A. Here's neither A or B. Also neither A or B. And then here's them all together, so it's a little easier. And now again, who thinks this is A? All right, 2 people. Who thinks it's B? Okay, most of you. Most of you think it's B. It's actually A. Why is it A? Because I said so. It's not your fault though. It's my fault as the trainer. I didn't show you good enough images to help you understand which this would fall under. So I get a lot of people think that this is B because it's at the different angles and the colors are similar and things like that. The reason why it's A, in my opinion, is I wanted you to focus on the red circle. So you can see in A, they both have red circles. This has a red circle. In B, we have an orange circle or a yellow circle. And in neither A or B, it's a pink circle and a red square. but that can be kind of hard for you to get by just looking at these few photos. But if I show you this, how many of you think this is A? It's not a trick question. Cool, like all of you. Any Bs? No, good. We're humans. We've been looking at images throughout our lives all the time. We know kind of what's important. If somebody holds out something and says, this is A, we know they're not talking about their hand or the background or anything. We know they're talking about what we're holding. But the machine learning model doesn't know that. So we're kind of just, we're forced to just show it lots and lots of images, and it can't really give us much feedback back of what it's focusing on. We just kind of have to keep, we have to think about the kinds of things we can show it to help it kind of hone in on what we're actually talking about. And one of the ways we can do that is by providing a negative data set. And in that, we could include photos of the hands, photos of the backgrounds, so it can kind of understand that you actually are talking about the apple. Cool. Yes?
So basically, if you have photos of the same fruit, it would be good to draw it by the apple you originally had. It would be good to train negative data to the other fruits. So if you're trying like just apple, you have an apple and the negative banana.
Yeah, so the negative class is kind of just like none of the above. So if you don't have like future plans of supporting other fruits in your model, then yeah, you can add them. But you don't, it's not really like you have a negative set for apples and for bananas. It's like one negative set for like, that's none of the above. That makes sense? Cool. Any other questions?
I asked something earlier about, but I'm wondering, it seems like this is built on linear regression stuff and math. Is that true? Because I did a quick search. It seems like it would be really useful with linear regression, you know, like you check to see the standard deviation. If it's high, then you know your model is not good.
Right.
So without being able to look at, you know, compare it, is there really no way to tell the quality of the, if it's truly using linear regression, it seems like there would be a way to say, this is how well we're trained.
Right, so what it's actually using is neural networks, and there's kind of like a trade-off graph. The better the model accuracy, the harder it is to interpret the results versus like a linear regression, it's a lot easier to interpret the results, but you're not going to get as good as accuracy as you would with a neural network. So there's a kind of a trade-off there. But things you can do are, it is good practice to split your data up into a training set and a test set and kind of run the test set on your model on your test set every time. And you can put together, like a lot of people use confusion matrices. So that kind of shows the like accuracy of, that's kind of hard to explain, but it kind of makes like a graph of what it should be versus what it shouldn't be, and I can show you pictures of that. But and then another thing you can do is let me pull something up. All right, so one thing you could also do is pass like a rectangle over your image and kind of chart down what happens to the confidence. So if you look here, it's almost impossible to tell what kind of cable that is. So you can kind of denote that as an important region versus in that photo, like our idea of what it is isn't hindered, so that we can label as not important. And we can do that like a lot of classifications, and then kind of end up with a sort of cloud of what region is important. So that's another way you can kind of see what the model is focusing on. Does that make sense? Any other questions?
So your point was the negative is very important to show you what to focus on.
Right.
You just tell them all the irrelevant areas and issues.
Right. Yeah, but it doesn't have to be like a negative set of like everything, because that would be a huge set. It's things that are like visually similar to the object that you're trying to classify, and things that are in that classification image that aren't what you're classifying. And then you can end up with like a photo like this. It had a decently high 76% confidence that it was USB, but if you do that thing that I was showing earlier, it wasn't actually focusing on the ends of the USB. It was focusing on the cable part. So you'd want to upload photos of more cables. And I did another demo where we trained it on beach balls and beer bottles. And whenever I held up the beach ball, took a photo, only my hand was highlighted what it was focusing on. So then I added photos of my hand to the data set, and it was a lot higher confidence. Whenever I took a photo of my hand, it wouldn't say beach ball anymore and stuff like that. Anybody else?
There's no issue with submitting this to the App Store that Apple might have a problem with?
No, no.
Generated code and uploading?
Right, so it's not changing the functionality of your app, so it's A-okay to use. And also another good thing to know, it's the model file itself is only 13 megabytes. And that doesn't change. Like, you can upload thousands of photos and it'll stay at 13 megabytes. Cool. Should I finish up? Do you have anything else?
Any other questions, we'll be here. I think we have this space for another about 15 minutes. So if you'd like to take some photos of cables that you can use to retrain it later, or if you want to do it right now, we're here to help you. It's basically the same process that we already did, just clicking retrain. But yeah, thank you guys for coming. Hopefully you got something out of it. And again, we'll be here if you have any other questions. So, and the workshop will stay live if you want to go through it once more. Awesome. Thank you.